Hi class, today's lesson is about linear motion. Class by Raj, teaching for Physics, Form 6, Semester 1. Kinematic is a subfield of physics developed in classical mechanics that describes the motion of bodies and system of bodies without considering the force that caused them to move. It is also a science of describing the motion of object using words, diagrams, numbers, graphs, and equation. Linear motion can be of two types. Number one, uniform linear motion with constant velocity or zero acceleration. Number two, non-uniform linear motion with variable velocity or non-zero acceleration. Linear motion is the most basic of all motion. Today's learning outcome, we are going to look at linear motion number 1, is to derive the equation of motion with constant acceleration. When you talk about linear motion, now there are 5 ways of describing a motion or 5 quantities to describe a motion. It's velocity, initial velocity, its final velocity, its distance or displacement, its time taken, or its acceleration. Today we are going to derive the equation of motion with constant acceleration. Constant acceleration means constant acceleration also can be called as uniform acceleration. It means velocity changes at a constant rate. Okay, now we are going to prove formulas for this constant acceleration. Okay, I'm going to give you all an example. Alright, I have a car here. Initial position was at x. Okay, initial velocity is u. Alright, and then the car traveled from one point to one point, which is point y, and the distance taken is s, or displacement, and at point y the final velocity is v, and the time taken from point y to point x to point y is t. Okay, so there are 4 quantities that is here that can be seen, which is u, t, s, and v. Okay, alright, so from here, from the concept here, we know that acceleration, the definition of acceleration is change of velocity divided by time taken. Okay, so in this case, the change of velocity from one point to another point will be the final velocity minus the initial velocity divided by time taken. Okay, so the formula will become A equals to V minus U over T. Alright, so from here, I reshuffle the formula. I will get V equals to U plus AT. Okay, so this is the first formula. Right, now the next one is a formula from the definition of velocity. Alright, so we know velocity is displacement over time. So in this case, we also know that displacement is equals to average velocity times with time. So in this example, average velocity is half u plus v, so times with t. Average, yeah, you must understand the word average. Average means what? So you must understand that. Average means purata, okay? There is another way of getting this concept. This is A, this is B. Before that, let me tell you, the formula becomes S equals to half U plus V times T. So this will be the next formula. Another way of getting this formula is by graphical method. Okay, if I have a graph, if I draw a graph of velocity versus time, at t equals to 0, it was initial velocity is u. After some time t, the final velocity is v. So the area under the graph represents the distance traveled or the displacement. So area under the graph is S equals to, is the area will be half U plus V times T. Okay, so you also can get it from the graphical method. They are the same class. Actually, they are same. It's just that one is by formula, another one is by graph. Okay, and then that's all from the concept, yeah. And then we use these two formulas, we can interpret another two formulas. Alright, okay, the first one, what can we do? Alright, we substitute number 1 inside number 2. Substitute number 1 inside number 2. Okay, S equals to half U plus V times T. Number 1 is V equals to U plus AT. So I get S equals to half U plus AT times T. So I get S equals to half 2U plus AT times with T. So you solve this, you will get S equals to UT plus half AT squared. So I'm going to write it with the black pen a bit bigger. Okay, this is your third formula. This is nothing new, yeah, class. This is just a revision of what you have studied before. So I'm just doing a revision with you all. Okay, so this is number 3. Okay, you combine 1 and 2, you get the third one. Okay, now let's see. Combining 1 and 2, you also can get another formula. Okay, from here, from number 1, V minus U is equals to AT. Okay, from number 2, V plus U, you get 2S over T. Okay, and then V minus U times with V plus U, you get AT times with 2S over T. So V square minus U square, you solve this and then you get 2AS. Then you will get
V square equals to U square plus 2AS. So I'm going to write it with the black pen. V square equals to U square plus 2AS. Your next formula. Formula number 4. Okay, so you have all these formulas together. Alright, formula 1 for linear motion under constant acceleration is taken from the definition of acceleration. Formula number 2 can be taken from the graphical method or from the formula S equals to average velocity times with t. Formula number 3 is actually a combination of number 1 and number 2. Same goes to formula number 4 is also a combination of number 1 and number 2, and then you get your formula. So there are 4 formulas. Alright, let's analysis on these formulas, class. Okay. Now from this formula, you will realize that there are only 4 quantities. Okay. Okay, let me take another color pen here, blue. There are 4 quantities. And what are the quantities? V, here got V, here got V, correct? Alright. And then we also have U, okay. Then we also have T. Then the last will be S and S. Okay. Oh, we have another one which is A. Okay, we have not 4, yeah, but 5. We have A. Okay, wait, let me take another color pen, which is A. Oh, okay, wait, A, A. So you will realize that there are 5 variables, and the way 5 variables are U, B, A, S, T. Each formula involve 4 of the 5 variables. Okay, like here we have 1, 2, 3, 4 variables. 1, 2, 3, 4 variables, 1, 2, 3, 4 variables, 1, 2, 3, 4 variables. So out of the 5 variable, each formula consists 4 out of the 5 variables in each formula. So you have to choose the equation that contains the 4 variable when you solve the question. Okay, class? So this is how to derive the formula or the equation of motion with constant acceleration. And you have to memorize this. Remember, the first 2 is based on concept. Thank you, class.
Our second learning outcome for today is to sketch the graph of displacement time, velocity time, and acceleration time for the motion of body with constant acceleration. We described a motion by formula in our first learning outcome. Now we are going to describe a motion by illustrating it in the form of graphs. There are 3 types of graph that can represent a motion: a displacement time graph, a velocity time graph, and an acceleration time graph. Linear motion graphs can easily represent the motion of an object. Now let's look on the first one, which is a displacement time graph. Now, displacement time graph, the y-axis represents displacement and the x-axis represents time. You see all these blue lines here? They are actually gradient and they equals to velocity. They speak about velocity. The y-intercept equals the initial displacement. That means sometimes when you have a line, a straight line like this, so this value here is y-intercept, and it equals the initial displacement. Like example, in this graph, the initial displacement is 0. A straight line represents a constant velocity. A curved line represents an acceleration. A positive gradient represents motion in the positive direction. Like example, if I have a point X and point Y, and the object is moving from point X to point Y, then we say the object is moving in the positive direction. So when you draw in a graph, you will draw it in like this, where your gradient will give you a positive gradient value. But if the object return back from point Y to point X, then the object is in the negative direction. Then you will get a negative value gradient. A zero gradient like this represent a state of rest. It's like a horizontal line. The area under the curve is meaningless. Now let's look at this graph. A zero gradient means it's a represent a state of rest. So in this case, the object is not moving. And in this case, the velocity is 0. A velocity time graph shows the speed and direction an object travel over a specific period of time. Velocity time graphs are also called speed time graphs. The vertical axis of a velocity time graph is the velocity of the object. The horizontal axis is the time from the start. This line is gradient, which is equals to acceleration. The y-intercept equals the initial velocity, which in this example, the initial velocity is 0. A straight line represents uniform acceleration. A curved line represents non-uniform acceleration. In this graph shows increasing speed. The moving object is accelerating. This graph shows decreasing speed. The moving object is decelerating. This graph, there's a straight line, straight horizontal line on a velocity time graph, which means that speed is constant. It is not changing over time. There is movement at a constant speed. The area under the graph represents or equal to the change in displacement. If the graph is above the x-axis, it is a positive velocity. If the graph is below the x-axis, then it is a negative velocity. The steeper the slope, the higher the value of acceleration. Or the steeper the gradient, the higher value of acceleration. Okay, in the acceleration time graph, okay, the gradient doesn't represent anything. It doesn't give a value for anything. Okay, the y-intercept here equals to the initial acceleration. So like in this graph here, you see the initial acceleration at time t0 is, say for example, 5 meters per second square. Then after some time t also is still the same. So we say it's a zero gradient, it's a horizontal line. So that means the object undergoing a constant acceleration. Okay, so first at 0 it was 5, and then after some time t it was still 5. So constant acceleration. But the most important thing, the area under the graph represents the change in velocity. Okay, it represents the change in velocity.